going to take each of these shapes and break them into non-overlapping triangles by drawing diagonals. So in this quadrilateral, I'm going to draw one diagonal from one corner to another corner, and I just created two triangles that make my one quadrilateral. Yes? Okay. The pentagon, we're going to do the same thing. We're going to choose a corner and then draw diagonals from that corner so that I have non-overlapping triangles. How many non-overlapping triangles did I get in my polygon? In my pentagon? 3 of them, right? Okay, let's do the hexagon and break it into non-overlapping triangles. You don't want any of the diagonals to cross for this experiment. None of the diagonals should cross for this experiment, okay? So are you guys filling these in for me? So choose a corner and then go across to a corner that's not next to it and keep doing that until you've done all of them and broken it into non-overlapping triangles. The reason you don't want them to be the reason you don't want the triangles to be overlapping or the diagonals to intersect is that would create more angles than we need in here. We want these triangles to have their angles in the corners of the polygon. Okay, so I've broken each one of these into triangles. How many triangles did we say we got in a quadrilateral? 2 triangles, because we don't cross over the top, so we just leave the 2 that are not overlapping. Okay, so this triangle here has 3 angles. So this angle plus this angle plus this angle, what does that add up to? Those 3 angles that I just highlighted in pink add up to 180, because every triangle adds up to 180. And now these 3 angles that I just highlighted in blue, what do they add up to? Those 3 angles add up to 180. So every triangle adds up to 180. I shouldn't hear talking. Every triangle adds up to 180. So if there's 2 triangles and each triangle adds up to 180, then I can go 2 times 180, and how many angles total, how many degrees total will be inside that quadrilateral? Good, 360. So the interior angles of a quadrilateral add up to 360, and also the exterior angles of a quadrilateral add up to 360, because the exterior angles always add up to 360. We just learned that, right? Interior angles are a little different, though. Let's look at the pentagon now. How many triangles did we break the pentagon into? 3 triangles. And how many degrees does each triangle add up to? Each triangle adds up to 180 degrees. So if there's 3 triangles and each triangle adds up to 180 degrees, that would be 3 times 180. Do the math for me. How many degrees will that add up to? Okay. Okay, the next one has 6 sides. It's the hexagon here. And how many triangles does the hexagon have? 1, 2, 3, and 4 triangles. And how many degrees does each triangle add up to? Each triangle of the 4 triangles adds up to 180. So 4 triangles, each of them times 180 degrees, is how many degrees total within a hexagon? 720 degrees. Okay, so a heptagon has 7 sides. How many triangles did we get out of our 7-sided polygon? 5 triangles. So we go 5 times 180, which is? I think it's just 900, isn't it? And then our 8-sided octagon has 6 triangles, and each triangle is 180 degrees. And so 6 times 180 is how many? 1080. Okay, now this last line here is for us to write like a formula. So n, we're going to say there's n sides and n angles. When there were 4 sides and 4 angles, there were 2 triangles. 5 sides and 5 angles was 3 triangles. 6 sides and 6 angles was 4 triangles. 7 sides, 7 angles, 5 triangles. 8 sides, 8 angles, 6 triangles. N angles, n sides. How many triangles? No. These numbers aren't the same. Write an equation for me that represents that. If these have 8 and this is 6, how do you get from 8 to 6? Or from 7 to 5? Or from 6 to 4? Down 2. What's another way of saying that? Subtract 2, minus 2. Okay, so can I call that n minus 2? Right? So n minus 2 triangles. And then what do we multiply that by for each triangle? 180 degrees for each triangle. So that gives us a formula, 180 times n minus 2, or n minus 2 times 180, whichever way you want to write it, it doesn't matter. It's the same idea. And n is the number of sides. So what if I tell you to find the interior angles of a 13-gon? Then what do you do? 13 minus 2 is 11. 11 times 180 gives you the total on the inside. This is a formula, correct? Okay, let's summarize the formulas we've learned today. Exterior angles add up to what? Nope. Exterior angles add up to 360. Interior angles, what do interior angles add up to? Not 180. N minus 2 times 180. Because where n is the number of sides. Okay, let's do a couple of examples. Number 3. Find the measure of the missing interior angle in the polygon below. And don't use protractors for these, just a little reminder of that. You're actually using the numbers and you're adding and subtracting to do the math. Okay, what shape is this? Let's count the sides. 1, 2, 3, 4. Quadrilateral. So what did we learn about this formula today? A quadrilateral has 4 sides. We go 4 minus 2 is 2. And 2 times 180 is 360. So this is 4 sides. We go 4 minus 2 times 180. So we're doing 2 times 180. Is that music in a different classroom or is it in the classroom? It's in. Okay, so the interior angles add up to 360. Is that the answer we're looking for? No, but that is an answer that we need in order to do this problem. So we have these 3 angles, but we don't have that one. How are we going to find the one that's missing? How do we find the one that's missing? We're going to add the ones together that we have. So 80 plus 65 plus 50. I need another person to verify Eli's answer. Okay, Logan, good job. Thank you. So we've verified that Eli is correct. So those angles add up to 195, and we need them to add up to 360. So what do we do? 360 subtract 195. Okay, I have a bunch of people verifying that they believe the answer is 165. Do you see how we found that? Okay. Number 4, find the measure of each interior angle of a regular octagon. So an octagon has how many sides? 8 sides. How many angles? 8 angles. Okay, let's use our formula. N minus 2 times 180. So we go 8 minus 2 times 180. So that means we're going to do 6 times 180. What's 6 times 180? We did it earlier. It's on the chart, so just a hint. 1080. That was the answer we got earlier. Is that our final answer? No, that's what all of the angles added together add up to. That's the sum of all 8 angles. Good. So we just want to find each interior angle, which means we want one of them, not all 8 of them added together, right? So somebody gave me the way we do that is by taking that answer and dividing by 8. Calculators ready? So each angle inside of an octagon is 135 degrees. So what if you wanted to create a stop sign using a protractor? What could you do? Make sure all of your angles are 135 degrees, correct? Okay, now I want to show you something really tricky about interior and exterior angles. This should be a no-brainer, but sometimes I have to point it out for it to make sense. If the angles, let me draw an octagon really fast to use here. Dun, 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 dun. Okay, so we just figured out that the interior angle is 135. We could find the exterior angle by taking 360 and dividing by 8, correct? What's another way to find an exterior angle? Okay, I want you to notice here we have a straight line. And here we have one angle and another angle next to each other that are forming a straight line. Angel? Yeah, they're adjacent. They add up to what? They add up to 180. So if this angle's 135, what's this angle going to be? Nope, 135 is obtuse. This angle's acute. 45. So what did you do to get that again? 180 minus 135 is 45. Now let's try it the other way. Do 360 divided by 8. 360 divided by 8. Did you get the same answer either way? Yes. So you might want to make a note to yourself somewhere. Note to self. One exterior and interior angle that are adjacent add up to 180. One exterior and interior angle that are adjacent add up to 180 degrees. So that's another way of being able to find the other type of angle after you've found one of them. Okay, that is all.